Will the blaze star finally explode on March 27, 2025? Or maybe it's November 10, 2025? Or perhaps after that? Those are the predictions of Jean Schneider of the Paris Observatory, published in the Research Notes of the American Astronomical Society in October 2024. Schneider came to his possible dates using a combination of the previous eruption dates and the orbital ephemeris of the binary system. While Schneider admits in his paper that no one can exactly predict the eruption, he is trying to predict eruption dates with a precision of a week or two. Will his predictions hold up? The only way to know for sure is to go out and observe Corona Borealis to see if a new star appears. Waiting for the blaze star to go nova. Have you ever heard of the blaze star? It's a star in the constellation Corona Borealis, the northern crown, that was supposed to go nova last year. Well, we're still waiting, but when it finally does erupt, it'll be a once-in-a-lifetime show in our night sky. The eagerly awaited blaze star nova is a real opportunity for keen night sky observers to witness a new star in the sky, but only for a few days before it fades away again. Here's more about why we're still waiting on the blaze star, and about how you can see when it does finally erupt as a nova. Why hasn't it happened yet? Predicting eruptions of stars is not an exact science. The blaze star, T Coronae Borealis, underwent two known eruptions recorded by astronomers. Those events were on May 12, 1866, and on February 9, 1946. Those eruptions were 80 years apart, so scientists thought that in another 80 years the star would erupt again. So, 80 years from 1946 would be 2026. Which raises the question, why did astronomers think the eruption would happen in 2024? Well, the star brightened and dimmed before its last eruption in 1946, and it has been brightening and dimming now as well, leading some to think the nova would happen sooner rather than later. But it appears as if later is more likely, and so we wait. In the meantime, here's how to find Corona Borealis and be ready to see it when the nova arrives. Why will it go nova? The blaze star isn't one star but two. It's a binary system with a white dwarf and a red giant. White dwarfs are stellar remnants, the exposed core of a sun-like star that shed its outer layers at the end of its main sequence life. It's a super-dense star with the mass of our sun but only the size of Earth. Blaze star's white dwarf has built up material on its surface, siphoned off from the red giant star. Periodically it just can't take no more and explodes about every 80 years. This is our best opportunity to see a nova with some warning. Plus, we have great visual context from the surrounding C-shape of stars. So cross your fingers for good weather when it happens. Where to look to find the blaze star? The constellation Corona Borealis is back from a month hiding below the horizon. It rotates around Polaris just outside of what we traditionally think of as the circumpolar constellations. This means it's not visible all year round for much of the northern hemisphere. The easy-to-find constellation looks distinctly like a backward C at this time of year. It lies between the bright star Arcturus and the squarish four-star shape of Hercules. Look east at the stars coming over the horizon before dawn. Find the bright orange star Arcturus. Then, to the bottom left of Arcturus is the backward C shape of Corona Borealis. Unless there's a guest star messing up the shape. By the summer, these constellations will be high in the sky again. You always need to spend some time dark adapting your eyes before you see the constellations properly. Plus, binoculars would be a good idea. And you need to be ready to go when we get the news, as it will only be there for a couple of days. How bright will the blaze star be? The actual explosion of the blaze star nova will likely dwarf any explosion you'll ever see, but the star is far away. How bright will it get in our sky? Astronomers expect it to reach an apparent magnitude of 2. That's a respectable brightness for a star. It's conveniently comparable to the brightest star in the northern crown, the jewel of the crown, Alphecca. So, for a few days, the northern crown will have 2 jewels. T Corona Borealis, the blaze star, is also one of the most distant stars you'll ever see. Alphecca is around 75 light-years away, while the blaze star is closer to 3,000 light-years away. So that gives you some perspective on the absolute magnitude or brightness of this enormous blast. And since the light of this explosion has traveled for 3,000 years to get here, in relative terms the nova happened during the Bronze Age. Remember that, when they are side by side with approximately the same brightness, the nova is 40 times farther away than Alphecca. Also, we are not seeing the two stars at the same moment in time. One we see as it was 75 years ago, and the other we see as it was 3,000 years ago. It can be hard to get your head around that. The nova will brighten the star by thousands of times, typically over just a few hours, and then take some days to fade away again. When it's done, it will go back to its normal appearance. Late at night in the spring and high overhead during summer months, find the bright stars Vega and Arcturus. Then locate the constellations Hercules and Bootes. The semicircle of stars between them is the constellation Corona Borealis. If you are not familiar with the Northern Crown, get out and have a look at it before this nova happens. And then, clouds willing, when it does erupt, we can go out and see the C shape is harder to spot. Instead, the dominant feature will be two brightish stars, Alphecca, the brightest star in Corona Borealis, and the Blaze star. The Blaze star is normally invisible to the unaided eye. On a regular day it sits at around magnitude 10, making it only the 19th brightest star in the constellation. But as it undergoes a colossal outburst of energy, it will brighten.